So hello everyone, today we are going to solve 6th and 7th problem. So let's start with 6th problem and read the question what it says and try to solve it. Okay, so question name is valid perfect square given a positive integer num, return true if num is a perfect square or false otherwise. A perfect square is an integer that is the square of an integer. In other words, it is a product of the same integer with itself. You must not use built-in library functions such as squared. Okay, so let's take an example one. Given the num equal to 16, we have to find if there exists a squared of 16, like 4 into 4 equal to 16. So okay, so question is pretty simple. Like we have a given num, anything, an integer num, let's say it's a 16, and we have to find squared without using inbuilt function. In C++, there is an inbuilt function of name squared, and if you pass 16 in it, then it will return 4. So uh, we have to return true or false if there exists perfect square root of the number, otherwise return false. Then how we are going to do? Like the brute force approach is like uh, you have you go to each and every element like 1 2 3 4 5 6 7 up to 16. Yes, now you go to each and every element and try to try to check if this element can be multiply itself to become 16. Like for this, 1 into 1 is equal to 16. Is this true? No, it's not. Then go to its next, that is 2. And for this you try to do 2 into 2 equal to 16. No, it's not. So then you will go to its next element, that is 3. Then you again try for 3. 3 into 3 equal to 16. This is again not. Then you go to next element, that is 4. Then if you try for 4, like 4 into 4 equal to 16, yes it is, then you will return this 4 as your answer. So this is the brute force approach. You are going from 1 to n, so the time complexity of this will become big O of num. Let's try to optimize this using binary search. Let's see how binary search apply in this case. Let me erase this all the things. Rather than going to each element one by one, we will calculate mid of this, and according to mid we will decide go to either we go left half or either we go to its right half. Let's see how. In the binary search we will put 2 pointers, low which is pointing to the very first element, and the high which is pointing to the very high last element. Okay, now we will find mid. How? We will write a formula for mid. Mid will be low plus high divided by 2. Here low is 1, high is 16 divided by 2. It is 17 divided by 2, and this will be 2 8 is 16. So 8. 8 is the mid. So let me write it 8 over here, and this will become our mid now. So let me mark it mid. So this is mid. Now we will check for mid. If this mid into mid equal to given num, if this condition is true, if this is true, then we are going to return what? This mid, because we find square root of num. Okay, perfect square. Now if it is not, like in this case 8 is 8 into 8 is equal to what is 64, and 64 is very large to 16, so we have to reduce this to reach 16. How we can do? Like we can go to its left half, so that its left half this and the right half this. In the right half, the element are present in the right half is always greater than 8, or in the left half it is always less than n. So we will prefer to go to its left half, because we have to reduce this thing. To reduce we have to go left side. So after going left side we do the same process, like we will shift this high pointer to the mid plus 1. So now it's pointing to high here. Now we will again do the same thing, calculate mid and compare this thing. Let's say if our mid value becomes like 2, now our mid will be 2. Now if you do multiplication with the same number, it will give you 4. Now 4 is quite low as compared to 16. Now you want to increase this. How can you increase this? By going to right side, because if you go to right side, let's say this is the mid and here it is 1 2 3 and 5 6 7. If you go to right side, then there is always the element present in the right side is always greater than 4. So your product will increase and you will able to reach near to 16 or 16. So this is the concept. Let's try to implement this with code so that you can understand it better. Okay, so int low will be equal to 1 and high will be equal to num. Now while low is equal to high, we will calculate mid equal to, what is mid? It will be low plus high divided by 2. Let me create a temp variable which will store mid into mid product. Now we will compare this t with num. If it is equal, that means we have found a perfect square, so we will return mid. If it is not, else if my product is very less, so I want to increase my product, so it will go to right side. So low will become mid plus 1, else our high will become mid minus 1. After that we will return minus 1. If there is no one, return not minus 1, we will return false. Actually we have to return true or false. If there is a perfect square, then we will return true. Let's try to run and see if it is running fine or not. Okay, so we will start with 0 because if num equal to, let's think a case like say num equal to 1, then there is no square root. 1 is a square root is equal to, yes, it is correct, I think. Let's try to submit this and see if it is correct or not. Okay, so signed integer overflow, so we have to take long. Okay, so long, and when we are comparing with long as well, and this is also long, maybe. I think that's enough. Let's try. Now let's use this test case. So, okay, this is correct now, and let me submit this again. Okay, so we are getting runtime error for 1 plus. Okay, to avoid this, we will low plus high minus low divided by 2. Let's use this test. This is for avoiding overflow. I think this would work. Yes, this is working. Let's try to submit this. Oh, sorry, this is not a high. I don't know how it is working. Like high minus high will be 0, and I don't know. But here should be low. Let's try to submit again. It's weird. Like again submit. So this is also correct, and that part also got correct. Okay, so let's move to the next question, that is square root of x. And this is very similar to this question, and I'm not going to do.